Everyone. So we're moving for the second half of this chapter into a topic called systems of equations. And a system, as you'll see in the definition here, is a set of two or more equations that include the same variables. And when we look at systems, we're often looking for the solution of the system. So what I want to point out is when we have an equation that's just in one variable, for example, so if I have 2x plus 1 equals 5. Because there's only one variable and we have it equal to a number over here, there is one possible solution here. There's only one possible value that makes this equation true. Okay? As opposed to if I write it like this, y equals 2x plus 1. Now I have lots of solutions. Okay? Let's see, I'll just jot this here. Lots of solutions that are all ordered pairs, okay? And so I can come up with many pairs of coordinates that would work here. I can put in a value for x, I can find the corresponding value for y, and then all of those ordered pairs are all solutions. They are all things that make this true, okay? So when I hand you a system, and a system is going to look something like you'll see down here in this example 1, each individual equation has a y and an x in it. So each individual equation has lots of solutions. And the solution to the system is the one set of numbers that makes both of them true at the same time. So there are lots of coordinates that are going to make this one true and lots of coordinates that are going to make this one true. And what I'm looking for is the one pair of coordinates that makes them both true at the same time. Okay? So just wanted you to really wrap your heads around what we mean when we say solutions. So there are actually lots of ways to solve these systems, and we're going to be working on them, like I said, for the rest of the chapter. But this first method involves graphing. Okay, so we're going to have to really remember how to graph linear equations here. I'm going to take this first equation, 1/3 x minus 4, and I'm going to put that here on my graph. So I'm going to start at my y-intercept of -4, put a dot, okay? And then my slope is 1/3, so I'm going to go up 1 and to the right 3. Up 1 and to the right 3. And I'm going to do this quite a few times just because for these types of problems, when you're graphing these things, it's really important that your line is nice and straight. Okay, I might even go the other way a couple of times. Down 1 and then to the left 3 would be right on the same line there. Okay, and then I'm going to connect those. And there's my line. Okay, so that's my first equation. My second one, y equals -x plus 4, is going to start at +4 on the y-axis. And then my slope here is -1, which is really like a -1/1. And that's telling me to go down 1 and then to the right 1. Down 1 and to the right, down 1 to the right, and I think you can kind of see where this is going. Okay. And so when I go to connect these, it ends up looking like this. And so the line here in pink is full of dots, even more than just the ones we plotted. Okay, this is an infinite number of points here that all make that first equation true. And the blue line is an infinite number of points that all make the second equation true. And can you see where the one place is that there's a point that makes both of them true? That would be this right here. Okay, this is what we call the solution to the system. This is what we're looking for today. Okay, and so then I'm going to find the coordinates here. This would be on the x-axis 1, 2, 3, 4, 5, 6, and then down 1, 2, I believe. So my solution would be 6, -2. Okay. And if I plug this point into both equations, that would be a great way to check and make sure that I'm correct. I'm just going to kind of do that mentally. Plugging in 6 for x, so 1/3 of 6 is 2, and 2 minus 4 gives me -2. And then -x, that would be -6, plus 4 would also give me -2 for y. So my solution checks out. Okay? That's really the big deal today, is that we're going to graph equations and then we are going to find the place where they cross. Okay? So lots of graphing, lots of point plotting, things like that. I do want to do one quick word problem example. And in this example, I'm going to be showing off how to do some stuff on your calculator too, so you might want to have that nearby and ready to go. Okay, so Mr. Weller's fencing in an area for a vegetable garden against the side of his house. He'd like to have an area of 72 square feet for his garden, and he has 26 total feet of fencing. Okay, so diagram of this situation. This is going to be the wall of his house, okay? And I'm not fencing along the wall of his house, so I am building a fence that looks something like this. Okay? Okay, and so what I'm going to do is I'm going to call this distance, I'm going to use X and Y here. I was about to use W and L, but I think it'll work better if I use X and Y. So I'm going to say this is Y, and then I'm going to call both of these X's because these both have to be the same length. Okay? So let's talk about an equation here for my possible dimensions. I have two pieces of information up here. I want to have an area of 72 square feet. So to get the area of this thing, my equation would be x times y, because that's length times width, has to equal 72. Okay? And then I have 26 total feet of fencing. That's kind of getting at perimeter there. So that means when I add all of these things together, it needs to equal 26. So x plus y has to equal 26. Okay? So take a second, just think back through that. Make sure that makes sense, where I got these two things from and how they became these equations. Because my next step is going to be to take each one of these and solve them for y. And they have to be solved for y for them to go into our calculator nicely. Okay? So here I'm going to go divide by x on each side. And I get y equals 72 divided by x. This one is really 2x plus y equals 26, right? And then I'm going to subtract that 2x from the other side, so I'm going to get y equals negative 2x plus 26. And then I'm going to go to my calculator and I'm going to graph these two things. So in my calculator, let's see what kind of glare I'm looking at here. First things first, if your plot is turned on like mine is, you want to turn it back off, okay? We only have the plots turned on when we're entering data, like in the stat button, okay? And again, I strongly encourage you to be going through these steps with me so that you can use them later. All I did there was I moved my cursor up to where it said plot 1 and I hit enter, okay? So I hit enter and that turned it on, okay, that's on. And then I moved it up there again, hit enter, and it turned back off. So my first equation, 72 divided by x. And my second equation is negative 2x plus 26. Now, I don't know what my window's set at or anything, so I'm going to go ahead and hit graph and see what happens. Oh yeah, my window's not set nicely. And you may be in this boat too, depending on what your calculator was used for last. So let's, just so everyone's on the same page, let's hit zoom, and number 6 will always take you back to your original window. Okay, zoom and number 6. And to be honest, this picture is not going to be too helpful either, but at least then we'll all be looking at the same thing. This up here is what I really want to see, okay? And we're going to talk about that in just a second. So let's get a nicer picture here. Let's look at our window, okay? That's defining what I want my graph to count by. And remember what x and y are meant to represent here. X and y are dimensions of a garden, okay? So my x min, it doesn't make sense to send it into the negatives. Really, the smallest I would ever want to go is 0, and even 0 doesn't really make sense, okay? And the largest my x could go, really, just as a rough estimate, because I have 2 of the same x's, and I need 26 total feet, the largest my x could go is like 13. I'm a big fan of multiples of 5, so I'm going to go up to 15, but I'm just kind of trying to set this window so that I'm seeing the part of the graph that actually makes sense to the situation, okay? And then go down to your y's. Again, it doesn't make sense to have negatives here, so let's go to 0 here. And then our y max, y could be a little bit larger, right? Because we only have one copy of y, and I drew it so that it was the longer side anyway. I'm going to go ahead and say, I mean, we could make y awfully close to 26 feet if I wanted to make this like a really skinny distance here. So I'm going to have y go up to 30. okay, just to make sure I can see everything I want to. Again, it's not going to make much sense to be that large, but just so we have an idea, okay? Now let's hit graph and see what we can see. Okay, so I hope this makes sense to you if you think back to when we did variation. This 72 over x, that's really a hyperbola, okay? So you're seeing a hyperbola here, and then this is a linear equation with a y-intercept at 26, okay? And it's going down by 2 and over 1. What I really care about here is where can I make both of these things be true at the same time? And that happens here and here. So for this next process, you may want to just watch me for a second. And then if you want, you could maybe pause the video and try it on your own, or maybe you try it for the second point after I've shown you the first one, okay? But here's what I'm going to do. I'm going to go to the Calc menu, which I'm not sure if we've used this yet, but Calc is up here above Trace. So second Calc. And what I'm looking for is the intersection. So I'm going to go to number 5. Now, you'll see my cursor's blinking on one of the two lines. Okay, mine's right now blinking on this first one, and it says first curve with a question mark. Okay, let me move this up so you can see what I'm doing. And so I'm just going to hit enter to confirm that that's the first curve. And then it says second curve, okay? And it's jumped to that other line that's drawn there. So I'm going to hit enter again to confirm. Now, this is where your calculator gets super annoying, because then it says, would you like me to guess? First of all, your calculator's not really guessing. And second of all, it's just being super insecure. It's just asking you, do you really want the answer now? Are you sure? Are you sure? All you have to do is hit enter one more time, okay, when it says guess. But you do have to hit enter. You can't just leave it where it's at. And then you'll see your cursor has jumped and it's blinking at the point 9, 8. Okay, so that's one of my possible intersections. Okay, we're going to repeat that process to get the other point with one minor change that we have to make, or one minor step we have to add. So I'm going to go back to Calc, go to number 5 for intersection. Okay, this time it says first curve, and it is blinking on the first curve, but it's where we left it, right? It's down by this intersection point. I'm just going to move it a little bit to the left here, just to get it so that it's closer to this point, because your calculator is always going to look for the intersection point that's closest to where the cursor is. So if I want it to find the other one, I just need to move it over, okay? And then I'm going to hit enter and say, yes, that's the first curve. Second curve should stay right in that same location, so I'm going to say yes to second curve. And then when it says guess, I'm going to hit enter one more time, and it's going to give me the coordinates 4, 18. Okay? So really what I just found out is that there's 2 possible dimensions I could make my garden, okay? I could make it so that I have, let's see, 9, 9, and 8, okay? Which if you multiply those, that's going to give you an area of 72. And if I add these together, 9 and 9 is 18, 18 and 8 is 26, so the perimeter here would be 26, which is what we want, right? Okay, or I could do it so that my x's are 4 and 4. And notice I drew this kind of out of whack. My 9 should be larger than my 8, and they're not, so ignore that. And then this side would be 18, okay? That would also give me an area of 72. And when I add those together, 4 and 4 make 8, 8 and 18 make 26. So this perimeter is also 26, okay? So my 2 dimensions, my 2 sets of dimensions that would work is a 9 by 8 or a 4 by 18. Okay, that's how I would answer this question. Okay, so really, I mean, you're going to see some problems similar to this. You're definitely going to see some nonlinear systems in this graphing section where you're having to graph stuff like this. For those, your calculator is going to be very helpful. Okay, even if you're just graphing it and then using the table to graph it on your paper would be fine. But I also wanted you to see how you can use this intersect menu, at least to check your answers, okay? I guess the other thing, while I have your attention, is I should show you that in the table you could find this as well, as long as they're whole number answers. If you scroll down here, you see x, and then you see y1 and y2. That's basically equation 1 and equation 2. But if I keep looking, do you see right here at 4, these 2 values match? That would be an indication that that's a solution. Everywhere else, they don't match. I see 2420, I see 3622, okay, but here they match. that means that 4 and 18 is one of your solutions. And I bet if I go down to 9, I would find another place where they match. Yep, 8 and 8 there. Okay, so you could find it in the table as well. The limitation of the table is it won't show you your answers if your answers are decimals at all. But the intersect thing would still work if they were decimals. Okay, so for tonight, you are jumping ahead in your homework packet. You are doing Lesson Master 5-2B, okay? And we will go over that in class when I see you tomorrow. Thanks a lot. Have a good one.